Hello, everybody, and welcome to this week's lesson. This week's lesson is Unit 11, Write, Solve, and Graph Linear Inequalities. For this lesson, you'll need pencil and paper, your welcome packet, maybe a calculator, and you might also find it useful to have your lesson notes from last week to hand as well. First thing you can do is go ahead and try the warm-up problem on the screen. So try this problem, and then when you're ready, restart the video and we're going to go through it together. All right, so this warm-up problem, it says solve 2x plus 10 equals 40. So this problem is from our Unit 10 from 2 weeks ago when we were solving one variable linear equations. And so we practiced with a lot of equations that looked just like this one. So whenever we're solving an equation, our number one goal is to get the variable by itself on one side of the equal sign. And to do that, we kind of follow a set process. What we have here is a two-step linear equation. We know it's two steps because when we look on the side with the variable, there are two operations. I see 2 times x, so there's multiplication, and I also see plus 10, so there's addition there. So it's going to be our goal to get that variable x by itself, so eventually by itself on one side of the equal sign. And so that means we're going to need to cancel out the plus 10. We're also going to need to cancel out that times 2. So following our process from Unit 10, I'm going to start with canceling out the addition first, right? So working kind of backwards through the order of operations. So how do I cancel out plus 10? Well, I subtract 10. That means this will go to 0. And then I have to do the same thing to the other side of my equation. So now, after I took that step, I'm left with an equation that looks like this. 2x equals 30. All right, so now I just have 2 times x that I need to cancel out. To cancel out that 2 times, I'm going to do the opposite. I'm going to divide by 2 on both sides. And so I'm left with x equals 15. If we have some extra time on our hands, we can go ahead and double check our answer by taking our value for x and substituting into our original equation. So I'm going to replace x with 15, and we're going to see if we get something that makes sense. So I have 2 times 15 is 30. And 30 plus 10 is 40. 40 equals 40. That's good. That makes sense. And so that means that our solution is correct. All right, so let's get into the lesson. Our learning goals for this week. By the end of this week, you will be able to solve linear inequalities in one variable, graph the solution to a one variable linear inequality on a number line, write linear inequalities to represent context, and solve real-world problems involving inequalities. So what we're doing this week is very, very, very similar to what we did in our last unit with equations. We are basically just expanding our focus from equations to also include other comparisons like inequalities. So we're still thinking about solving, writing, and graphing. We're just going to be doing it with inequalities this week instead of equations. So if you have not watched the lesson for Unit 10 about writing and solving equations, you should definitely go back and work through that lesson first. Try that homework first, and then come back to this lesson. All right, so we're going to start off by doing a little review of solving equations. I highly encourage you to pause the video, give these 3 problems a try, and then come back to the video when you are ready. All right, so the first example here, 25 equals x over 3 minus 5. We want to focus on the side with the variable, and it's our goal to eventually get that variable by itself. So I'm going to tackle addition and subtraction first. So I'm going to tackle that minus 5. How do I cancel it out? With a plus 5. That'll go to 0. Same thing to the other side. And so I have x over 3 on the right side, and I have 30 on the left side. So now I have this dividing by 3 that I need to cancel out. To cancel out division, we multiply. Same thing to the other side. And so we are left with x equals 90. And that's our solution. We can double check our answer by returning to the original equation and substituting 90 in place of x and following the order of operations to do the calculation. So 90 divided by 3 is 30. And 30 minus 5 is 25. So that makes sense. That's good. And that means that our solution was correct. All right, on to the next example. 2x plus 3x equals 45. So this is an instance of where our variable shows up in multiple terms. So what we want to actually do here is we want to tidy things up as much as we can before we go ahead and start canceling things out. So this goes back to the general process for solving equations that I discussed in the Unit 10 lesson video. This is where we need to combine like terms. And we want to remember that like terms are terms that have the same variable with the same exponent. So here I have two terms that have the same variable and there's no exponent, so they have the same exponent. And so what I'm doing here is I'm basically saying, well, if I have 2x's plus another 3x's all together, if I combine them, I have 5x's. Right? So just tidying up the left side of the equation there as much as possible. Okay, so now this is a one-step equation. All we need to worry about canceling out here is this multiplication by 5. So I'm going to divide both sides by 5. So I'm left with x equals 9. And let's check our work. We have 2 times 9 plus 3 times 9. Does that equal 45? Well, I'm going to follow the order of operations here. 2 times 9 is 18. 3 times 9 is 27. And 18 plus 27 is 45. So everything checks out here, and that means our solution was correct. On to the third example. -1 minus 4m equals -28. So I want to take care of this -1 first. How do you cancel out -1? To make it go to 0, well, we would add 1. Same thing to the other side. Now with this problem, you really want to be careful with your positives and negatives. So -28 plus 1, that is equal to -27. Right, when you add 1, you should be increasing, you should be getting more positive. Yeah, so if we start with -28 and we add 1, we're gonna get a little bit closer to the positive side of things. We're gonna get to -27. Okay, and our next step here is to cancel out the multiplication by dividing by -4. Make sure you divide by -4, don't just ignore the negative sign there. Okay, so -27 divided by -4. I know that 2 negatives make a positive, so I know my answer is going to be positive, but 4 doesn't go into 27 evenly. I know it's going to be some kind of a decimal answer. So I just got out my calculator here. 27 divided by 4 is equal to 6.75. And if you'd like to, you could go ahead and double check that answer. Okay, so now let's get a little bit of extra practice with some equation word problems. First one here says, Nina made some money babysitting last week. George made $4 less than twice what Nina made. The two of them together made $56. How much money did Nina make? Okay, so one way that we can solve this problem is by writing an equation. and then solving that equation. So this situation has a really typical setup where it tells you a total amount, and then it describes to you kind of what are the components that go into this total. So this problem is talking about these two people who are babysitting all together. They made $56. And then it gives us some details about how much the two people made. So I know that that $56 is going to be equal to whatever Nina made plus whatever George made. So I often really like to start setting up my equations this way where, I don't worry too much about the algebra at first. I just kind of set up an outline of my total amount on one side and then like what is going into that total on the other side. Not all problems involve totals like this, but many of them do, so you want to be on the lookout for it. Okay, so now let's think about what we're going to replace where Nina and George are. So it says Nina made some money babysitting last week. And then our question says, how much money did Nina make? So we don't know, right? We don't know how much money Nina made. She made some amount. And then if we look at the next sentence, it actually describes what George made in terms of what Nina made. So if we knew what Nina made, we could figure out what George made too. So that means that Nina is our unknown here. If we can figure out what Nina made, we can figure out what George made too. So I'm just going to say whatever Nina made, let's call that N. So I'm replacing the name Nina with N for short. And then let's think about George. So George made 4 less than twice what Nina made. So George made twice what Nina made and then 4 less than that. So take away 4, right? 2 times whatever Nina made and then take away 4. So I've got Nina right here. I've got George right here. All together, they made $56. Okay, so now we have an equation that represents the situation, and now we can solve it. So N plus 2N minus 4 equals 56. Okay, so first thing I'm going to do here is do a little tidying. I see that I've got a couple of like terms that I can combine. Remember, like terms have the same variable with the same exponent. So if I have 1n and then I have another 2n's, altogether I have 3n's minus 4 equals 56. Okay, so now this is a pretty typical 2-step equation for me to solve. I'm going to cancel out that minus 4. $56 plus 4 is 60. And I'm going to cancel out that multiplication by 3 by using division. And so we're left with n equals 60 divided by 3, which is 20. So we want to remember, right, that n stood for what Nina made. That's what n stood for. And so we've just figured out what Nina made. Let's go back to the original question and make sure we're actually answering the question. So it said, how much money did Nina make? So yes, we actually did answer the question. The question was, how much did she make? And so we could say Nina made $20. You always want to make sure and double check that you're actually answering the question, because if the question had said, how much money did George make, we would have set up and solved the same equation, but then we would have had one more step to go and calculate what George made in addition to what Nina made. So always double check your answer, make sure you're answering the question, not just what you think the question is. All right, next word problem here. Elaine bought $80 worth of quarters to use for laundry. She uses the same amount each week. After 4 weeks, she had $54 left in quarters. Which of the following equations shows the amount Q that Elaine uses for laundry each week? Okay, so let's think about, oops, I think I made a mistake when I set this up. Let's say, which of the following equations shows the amount X the amount X that Eleni uses for laundry each week, because we're talking about the letter X in these answer choices. Okay. So X is the amount she uses each week. She uses the same amount each week. She started with 80, and then she used her quarters for 4 weeks, and after those 4 weeks, she had $54 left in quarters. So let's take a second to go through each of these answer choices and see if they make sense. Choice A says X. So remember, X is the amount she uses for laundry each week. So the amount she uses for laundry each week plus 4 weeks equals 80. That doesn't quite make sense to me, right? The 80 is the total amount of quarters she started with. X is a smaller amount of weekly money that she uses, and then you're adding 4 weeks to that. One thing you want to be on the lookout for is you can't add together different types of stuff. So it doesn't really make sense to talk about adding dollars and weeks, right? Just like it wouldn't make sense to talk about adding together, I don't know, apples and unicorns, right? They're just like 2 different types of things. So you can't like tally them all together. So that's the main issue that I see with choice A here is it's trying to add together a dollar amount with a number of weeks, which doesn't really mean anything. It certainly doesn't give you $80. So A is not going to work. Choice B is saying the amount of money she uses each week divided by the number of weeks equals 54. Now that doesn't quite match up with the information we're given here, right? We're told she has $54 remaining or $54 left after 4 weeks. It doesn't say that we take some amount divided into 4 pieces and you have $54. So choice B isn't going to work either. Choice C, so choice C is saying $80, so like her starting dollars, minus 4 weeks, 4 weeks times the number of dollars per week equals what she has left. So her dollars that she has left after 4 weeks. Now I think this one makes quite a bit of sense, right? She starts with $80. She uses the same amount of money each week for 4 weeks. And so at the end of it all, she's got some amount of money left. So choice C is our correct answer here. If we move on to choice D, we'll see that choice D is close, but it doesn't quite work because it's saying you start with $80 and then you add money to get up to 54. That doesn't really match this situation, right? She's spending money, she's getting rid of it for 4 weeks. She's not adding it on to the $80. All right. So let's move on to our main subject for this week, linear inequalities. So far we've been talking about equations, which is a statement that 2 things are equal to each other. But we can also have inequalities. So an inequality is a mathematical statement just comparing 2 expressions, so not specifically about them being equal to each other. So there's 4 different symbols that we can use for inequalities. We've got is less than or equal to, is greater than, and is greater than or equal to. And so we can have, very basic comparisons like 1 is less than 2, 2 is greater than 1. We can have something with a variable in it. So we could have 1 plus some number is less than 5, or 6 minus some number is greater than 1. We could have some number, right? We're talking about some number that's less than or equal to 10, or we could have 20 is greater than or equal to 2 times x, 2 times some number. So one thing you want to start noticing here is that when we have these variables in the inequalities, there actually ends up being many different values that would satisfy those variables, right? This is just saying 1 plus x is less than 5. So there's actually a bunch of different numbers that x could be to make that inequality statement true, right? Like if you did 1 plus 1, that would be less than 5, that would work. If you did 1 plus 3, that would be less than 5. If you did 1 plus 0, that would be less than 5. If you did 1 plus -4, that would be less than 5, right? So something that is kind of special about inequalities compared to equations is that the solutions or the values that the variables can take on, there are often like infinitely many solutions, right? So there's like a group of solutions instead of just one single solution. So we're gonna be talking more about that later on when we get to solving inequalities. Okay, so inequalities versus equations. With equations, right, you're just talking about something being equal to. And we've already seen a lot of word problems for equations. So we know that the equal sign means that it's equal to, and there are other common phrases that can show up in word problems that tell you you're talking about an equal kind of situation. Well, for each of our inequality symbols, we know what they mean, right? We know like the exact translation, but there are also other common phrases that can tell us, that can give us a hint about which of the inequality symbols we are using. So I would highly recommend that you pause the video and you copy down this table or take a picture of it, put it somewhere safe where you can refer back to it as you are working on your practice problems for this week. So let's look at the example down at the bottom here. It says a child must be at least 4 feet tall to go on the ride. Represent this as an inequality. And so I have done that right here. I've got H for height because we're talking about how tall they are. So the child's height, it must be greater than or equal to 4 feet, right? Because it says at least 4 feet tall. That means the kid could be 4 feet tall, but they could also be more than 4 feet tall. And when I go back up to my table here, I see that the phrase at least does go with greater than or equal to. All right, so let's write some more basic inequalities. Number 1, your insurance covers up to $1,500 in damages. So it could be less, right? Let's say I for your insurance. Your insurance could pay you less than $1,500. It could pay you $1,500, but it's not going to go over $1,500. So what your insurance covers is going to be less than or equal to $1,500. Number 2, the moon bounce is for children 4 feet and under. So let's say let's say we're talking about height again. So the height, it can be equal to 4 feet. It can also be under 4 feet, right? So the height is less than or equal to 4 feet. Number 3, you must be at least 18 years of age to vote. So let's say your age must be at least. So you can be equal to 18 years old. You can be more than 18 years old in order to vote. Number 4, the positive test rate is higher than 7%. So let's say T for test rate. It is higher than, so it's not 7, it's not less than 7, right? It's over 7, it's higher than 7. So the test rate is greater than 7%. Okay, so now let's write some less basic inequalities. Let's talk about some inequalities that we can maybe solve and figure out the missing value to. So number 1 here, it says Donnie must read Donnie must read at least 300 pages for his philosophy class this week. Choose the inequality below that represents what his daily page goal should be. So let's imagine you're in this situation, right? You've got a week ahead of you, and you've got to read at least 300 pages by the end of the week. So you need to get to 300 by the end of the week. And you're setting how much do you need to do each day. So let's look at these answer choices here, A, B, C, and D. They're all set up kind of similarly. So they're all saying 7 times something, and then that has some relationship to 300 pages. So let's first ask ourselves, why is there a number 7 here? Because the problem doesn't explicitly say anything about the number 7. Well, it's because we're talking about a week and we're talking about a daily page goal, right? So there's 7 days in the week times the daily page goal, right? That should get us to our goal of 300 pages. So when we do 7 days times the number of pages we read each day, it could be equal to 300, right? Or it could be over 300. It just can't be less than 300. That wouldn't be good. So for this problem, we would choose A. 7x is greater than or equal to 300. So 7 days times our daily page goal should be greater than or equal to 300. And so we're going to see this more later, but we could actually go ahead and figure out what the daily page goal should be. So if you want to get to 300 pages, then I'm going to solve this just like an equation, right? It should be that x is greater than or equal to 300 divided by 7, which is equal to 42.857 pages per day. I'm going to round that off to 42.9 pages per day, let's say. So basically, if you read 43 pages a day, you will meet your goal. All right, but this was just extra here. We're going to talk more about solving inequalities in a few minutes. All right, number 2. Darla can pay at most $100 to order new ID cards for her workers. So at most $100. The cards are $2 each plus $5 shipping. Choose the inequality that represents the number of cards Darla can order. So I looked at my answer choices here. I'm guessing that C is standing for the number of cards that she can order. All of these answer choices have the same basic setup, where we're saying $2 per card times the number of cards plus $5 shipping should be related to $100, right? She can pay at most $100. So the question is, what does this at most tell us? Well, it tells us we can go up to 100, right? It could be 100, it could be less than 100. We just can't go over 100. So she needs to keep her costs less than or equal to $100. All right, so solving one variable linear inequalities, that's what we're going to talk about next. Solving these linear inequalities is the same process as solving an equation. So everything that you learned in the last lesson, you're going to use all of that knowledge plus one more thing. So one more thing we need to keep in mind when we're working with inequalities. Whenever you multiply or divide both sides by a negative number, the inequality sign flips. So let me give you an example. Let's say we have negative 2x plus 4 is greater than 8, let's say. So I'm going to solve this just like I would any other equation. So I'm going to subtract 4 from both sides. I'm left with negative 2x is greater than 4. And now, right, to get that x by itself on one side of the inequality, I need to divide by negative 2. Both sides, I'm going to divide by negative 2. So since I have just divided both sides by a negative number, that means that the inequality sign is going to flip. So it's going to go from greater than to less than. So this is my final number here, that x is any number less than negative 2. And we could double check that that makes sense. So let's pick a number less than negative 2. So let's just do the next one. Let's do negative 3. That's less than negative 2. So negative 2 times negative 3 plus 4, that should be greater than 8. So negative 2 times negative 3, a negative times a negative gives us a positive 6 plus 4. 6 plus 4 is 10, which is in fact greater than 8, right? So that works out. That means that our solution was correct. Okay, so keeping that one extra fact in mind, let's practice solving these linear inequalities. So I would go ahead, pause the video, see if you can solve these, give them a try, and then come back when you're ready to go through the answers. So number 1, I'm going to cancel out that multiplication by 3 by dividing both sides by 3. So I'll be left with x is less than 7. And we can check our answer. We're saying x must be less than 7, so let's pick a number less than 7. Let's do 6. So I'm going to go back to my original inequality, substitute my number, 3 times 6. 3 times 6 is less than 21. Is that true? Well, 3 times 6 is 18, and that is less than 21. And so our answer was correct. All right, number 2. I've got x over 2, or x divided by 2, is greater than or equal to 10. So to cancel out that division by 2, I'm going to multiply both sides by 2. And I will have x is greater than or equal to 20. And so we can check our answer. Let's pick a number that's greater than or equal to 20. Let's do 30. So 30 divided by 2, that should be greater than or equal to 10. So 30 divided by 2 is 15, which is greater than or equal to 10. So that works. That means our solution was correct. So when you're checking your answers, right, you don't have to pick these numbers that I'm picking. You can pick any number that meets the criteria of your solution. So you could have picked 20, you could have picked 20.1 if you wanted to, you could pick 500, whatever you want, as long as it's greater than or equal to 20. All right, 4 minus 2n is less than or equal to 8. So I'm going to cancel out this 4, right? 4 minus 4 goes to 0, disappears. Subtract it from both sides, so we're left with negative 2n is less than or equal to 4. All right, now to cancel out this multiplication with negative 2, I'm going to need to divide by negative 2 to both sides. So I have n, and then I'm going to flip my sign because I just divided both sides by a negative number. So if I multiply or divide both sides by a negative number, I have to flip it. So I'm left with n must be greater than or equal to negative 2, because 4 divided by negative 2 is negative 2. And let's check. So a number greater than or equal to negative 2, let's pick 0, right? 0 is greater than negative 2, so that'll work. So 4 minus 2 times 0, that should be less than or equal to 8. 2 times 0 is 0. So we have 4 minus 0 is less than or equal to 8. 4 minus 0 is 4, which is less than or equal to 8. That makes sense. And so our solution seems to work out. All right, and then number 4, I'm going to cancel out that addition first, right? Cancel out that plus 2. Same thing to both sides. I get negative 4 times m is less than negative 12, right? Negative 10 minus 2 is negative 12. All right, now I'm going to divide both sides by negative 4. And so that means I'm going to have to flip my sign. I'll get m is greater than 3. And I'm going to leave it up to you to pick a number greater than 3 to plug back into the original inequality and check and see if this answer is correct. All right, so the last main skill we're going to practice today is graphing one variable inequalities. So this is a way where we visually represent the solution to a one variable inequality using a number line, right? Because when we are writing these inequalities, the variable doesn't just have one value, right? It has a whole set of values, a whole list of possible numbers that fit the criteria of the inequality. So the way that we graph these is we put a circle around the number that we're talking about. It's going to be an open circle if we're using the less than or the greater than sign. And it's going to be a closed circle if it's the less than or equal to or the greater than or equal to sign. So open if it's less than or greater than, closed if it's less than or equal to, greater than or equal to. And then we're going to put an arrow pointing towards all of the other numbers that are included in our set. So let's go through these examples here. I think that'll make it easier to see. So x is less than 2. So I'm going to put an open circle around 2 because we're not actually including 2 here, right? X can't be equal to 2, but it can get really, really close to 2. 2 is just kind of the boundary of what we're talking about. So x is less than 2, x is less than 2, so I'm going to put an arrow pointing towards all of the numbers less than 2. You can also notice that the arrow basically points in the same direction as the inequality sign. All right, let's come over here to x is less than or equal to negative 1. So we're talking about negative 1, and it's less than or equal to, so it's going to be a filled in circle because we're including negative 1. And it's less than, so I'm going to point to all of the numbers less than negative 1. Again, notice the arrow's pointing in the same direction as the inequality sign. All right, x is greater than negative 3. Open circle around that negative 3. And I'm going to point to all of the numbers greater than negative 3. And x is greater than or equal to 0. Closed circle on 0. And I'm going to point to all of the numbers greater than 0. So that's how you graph a one variable inequality. So we're going to solve and then graph the solutions to the inequalities using a number line. We've actually already solved these inequalities today, so I'm just going to show you what it looks like. So we get x is less than 7. Now I'm going to show that on a number line. We're talking about the number 7. It's going to be an open circle because we're not including 7, right? We're just going up to 7. And then we want to point to the numbers less than 7. Notice I didn't fill in any other numbers here. That's because I don't really need to, right? Number lines are always set up the same way, where when you travel to the right, you're increasing. When you travel to the left, you're decreasing. So I know that by pointing my arrow to the left, I'm pointing to all of the numbers smaller than 7. So you might sometimes see these graphs set up in this simpler way. All right, number 2, I'm going to solve this. Again, just taking the same steps that we took before. I need to flip my sign because I divided by a negative. Okay, and then I'm going to graph this. It's going to be a closed circle around 3. And I'm going to point to the numbers less than 3. All right, and that is how you graph these one variable inequalities. All right, so we're going to finish up today by doing a few practice problems. So using inequalities, writing them and solving them to describe more real-world situations. So number 1, to ride the tornado blast roller coaster, you must be at least 54 inches tall. At least 54 inches tall. Choose the inequality that represents this situation. So our height needs to be at least 54 inches. So it could be equal to 54 inches, right? That would be fine. It could be more than 54 inches. It just can't be less. So our height needs to be greater than or equal to 54 inches. Number 2, to ride the tornado blast roller coaster, you must be at least 54 inches tall. So same setup. Graph the inequality h is greater than or equal to 54 on the number line below. So we're basically just graphing our answer from the last problem. So it's going to be a closed circle around that 54. And we're going to point to all of the numbers greater than 54, right? Because we could be 54 inches tall, or we could be 55, 56, 57, 58, and so on, right? We could be any height that's 54 inches or bigger. All right, number 3. Ronaldo is purchasing face masks for his business. He may spend no more than $100. Masks are 50 cents each plus $20 shipping. First, write an inequality representing the number of masks n that Ronaldo can purchase. Then solve the inequality. Finally, graph the solution on a number line. So we have sort of a 3-step problem here. We got to write an inequality, we got to solve it, and then we got to graph the solution with a number line. Now, the actual situation here is really similar to the word problem we had earlier with Darla, right? Darla was paying $100 for ID cards. The cards were $2 each plus $5 shipping. This is a similar situation, right, where we've got a total amount we can spend. So no more than $100. We can go up to $100. So what we're doing here is we're writing the inequality. We can go up to $100, right? We can be under it, we just can't go over it. So we need to be less than or equal to $100. Now what goes into that $100? Well, we know it's 50 cents each. So 50 cents times whatever number of masks we buy. I'm going to simplify that to just 0.5 instead of 0.50. So 50 cents times the number of masks plus $20 of shipping, right? So this is how we would calculate the cost of the masks. It's 50 cents times the number of masks we order plus an extra $20 for shipping. That cost can be no more than $100. So this is our inequality. We have written an inequality representing the number of masks that Ronaldo can purchase. So now we're on to step 2 here where we solve. So 0.5 times n, or 50 cents times n, plus $20, less than or equal to $100. So first thing I'm going to do, cancel out that addition. Same thing to both sides. 100 minus 20 is 80, and we've got 50 cents times n over here. Now I want to cancel out that multiplication. with division. Same thing to both sides. Then I'm left with n is less than or equal to, so 80 divided by 50 cents, or 80 divided by like $0.50, that's going to be 160. 160. So n, right? N is the number of masks. Ronaldo can purchase up to 160 masks. If he buys more than that, he's going to go over his $100 limit. So here is our solution. And then the final step here is to graph. So I'm talking about the number 160. I'm going to put a closed circle around that because it's okay for him to buy 160, right? That would put him at exactly $100. But he can also order less than that amount. So we include 160 and then we point to all of the numbers less than that as well. All right. So that is all I have for you today. Thank you so much for joining me in this lesson. Like I said, I would highly, highly recommend going back and taking a look at the Unit 10 lesson where we talked about equations, especially if you found this lesson a little bit tricky. Good luck on your homework this week. Please let me know if you have questions or if you would like some extra practice. And I hope you're all doing really well. Take care.